Imagine a tiny sneaky organism, so small you can't see it, but powerful enough to cause big problems for our food supply. That's a fungus called Fusarium graminearum. Recently, this fungus made headlines because a scientist was found guilty of smuggling it into the United States. This news, dated November 12, 2025, brought a lot of attention to the world of biosecurity and the rules we have to protect our farms. This situation reminds us that even microscopic life forms can pose a significant threat if they are not handled with extreme care and respect for the laws designed to keep our agriculture safe from harm. So, what exactly is this fungus? Fusarium graminearum is a type of mold that acts as a plant pathogen, which is a sciencey way of saying it's a germ that makes plants sick. It's actually quite common in the United States and other parts of the world where certain crops are grown. This fungus is not picky. It loves to attack some of our most important food sources. It's particularly famous for causing a disease known as Fusarium head blight, or simply scab, in staple crops like wheat and barley. It doesn't stop there though, as it also causes serious damage to corn, where it leads to ear and stalk rot, and even affects rice crops. When this fungus infects a plant, it does some serious damage that you can see. In wheat and barley, the infection often happens during the flowering stage. The fungus attacks the head of the plant, which is where the valuable grains are formed. Infected grains often become shriveled, discolored, and lightweight, sometimes showing a pink or orange-ish mold. This condition, called scab, drastically reduces the amount of good grain a farmer can harvest from a field. In severe cases, a farm's yield can be cut down by nearly half, which is a devastating loss for the farmer, and a big problem for our food supply chain. The economic impact of this tiny fungus is truly staggering. Think about all the bread, pasta, and cereal we get from wheat, or the beer made from barley. When Fusarium graminearum attacks, it's not just a few plants that suffer. According to the United States Department of Agriculture, this single fungus costs American wheat and barley farmers more than $1 billion every year. For example, in 2024 alone, it was estimated that the fungus destroyed about 31 million bushels of the U.S. wheat crop. That's a huge amount of food that never made it to our tables, all because of a microscopic plant disease. The damage caused by Fusarium graminearum goes beyond just shrinking the harvest. This fungus produces a dangerous chemical substance called a mycotoxin. Myco means fungus, and toxin means poison, so it's literally a fungus poison. The specific mycotoxin this fungus creates is often called vomitoxin, and its name gives you a pretty good clue about what it does. This toxin contaminates the grains that the fungus has infected, so even if the grain looks okay, it might still contain this hidden danger. This makes the fungus a threat not only to the quantity of our food, but also to its safety for consumption by people and animals. When humans or animals eat grain contaminated with high levels of this vomitoxin, it can cause serious health problems. As its nickname suggests, ingesting a large amount at once can lead to symptoms like vomiting and an upset stomach. But the danger doesn't stop there. Long-term exposure to even small amounts of the toxin can cause more chronic issues. It can damage the gastrointestinal system, weaken the immune system's ability to fight off other illnesses, and even cause inflammation in the central nervous system. This makes it incredibly important to keep this toxin out of our food supply to protect public health. Because of these health risks, government agencies have set strict rules for how much vomitoxin is allowed in our food and animal feed. In the United States, the Food and Drug Administration has established advisory limits. For food products that humans will eat, like flour for bread or cereal, the limit is very low, just 1 part per million. For animal feed, the limits are a bit higher but still carefully controlled. For example, the limit is 10 parts per million for adult chickens and cattle. If a farmer's truckload of grain is tested and found to have toxin levels above these limits, the entire load can be rejected, resulting in a total financial loss for that crop. These safety limits are a critical line of defense. They ensure that the grain that makes it into our food system is safe to eat. The process of testing and enforcing these limits helps protect everyone, from the farm animals that might eat the grain, to the people who rely on it for their daily meals. The presence of these toxins is a powerful reminder that the health of our crops is directly linked to our own health. Keeping fungi like Fusarium graminearum under control is a vital part of ensuring we all have access to a safe, reliable, and healthy food supply. It's a big responsibility that starts on the farm. The recent smuggling case highlights why there are such strict laws about moving plant diseases around. In the United States, the Plant Protection Act of 2000 gives the Department of Agriculture's Animal and Plant Health Inspection Service the authority to regulate things like Fusarium, graminearum. You can't just decide to move a plant pathogen, even for scientific research. Scientists need to apply for a special permit, a process that can take many months and involves a thorough review to ensure it will be handled safely. These laws exist to prevent the accidental or intentional release of dangerous pathogens that could devastate our country's agriculture and natural ecosystems. Understanding how this fungus spreads is key to controlling it. Fusarium graminearum is very good at surviving from one season to the next. It hides out on the leftover plant material, or residue, from previous crops like corn stalks or wheat stubble left in the field after harvest. When the weather gets warm and wet, the fungus wakes up and starts producing millions of microscopic spores. These spores are like tiny seeds that are so light they can be carried long distances by wind currents. This is how the fungus can travel from one field to another, or even from one farm to the next, spreading the disease over a wide area. The timing of infection is crucial. The fungus usually attacks plants during their flowering stage, which is a very vulnerable time for the plant. The perfect conditions for an infection to take hold are periods of high humidity and rainfall, which help the spores land on the plant and start to grow. A few days of rainy, warm weather, while wheat or corn is flowering, can lead to a severe outbreak of scab. Because the spread is so dependent on the weather, farmers have to be constantly vigilant during this critical part of the growing season, watching both their crops and the weather forecast very closely. The ability of spores to travel on the wind makes this a community-wide problem. One farmer's field with a lot of infected residue can become a source of spores for all the neighboring farms. This is why managing the disease requires a coordinated effort. It's not enough for just one farmer to take precautions. If others in the area don't also manage their fields properly, the risk of infection remains high for everyone. This shared vulnerability underscores the importance of widespread agricultural best practices and why preventing the introduction of new, potentially more aggressive strains of the fungus through smuggling is so incredibly important for our national food security. Fortunately, farmers are not helpless against this fungal foe. They have several strategies like an integrated pest management plan to protect their crops. One of the most effective methods is to plant crop varieties that have been bred to be more resistant to scab. While no variety is completely immune, some can fight off the infection better than others. Another important tool is the strategic use of fungicides. These are special chemicals that can suppress the fungus and reduce the amount of mycotoxin it produces. However, timing is everything. The fungicide must be applied at just the right time to be effective. Beyond chemicals and genetics, farming practices themselves play a huge role. Crop rotation is a powerful technique where a farmer will plant a different type of crop in a field each year. For example, planting a non-host crop like soybeans after a wheat crop can help break the disease cycle, as the fungus cannot survive as well on soybean residue. Another method is tilling, or plowing the field after harvest. This buries the infected crop residue under the soil, which makes it much harder for the fungus to survive the winter and release its spores the following spring, reducing the risk of a new infection. Science is also providing farmers with new, high-tech tools to join the fight. Researchers at several universities, including Kansas State and Ohio State, are working on a sophisticated computer model to predict the risk of a scab outbreak. This forecasting system uses historical weather patterns and up-to-the-minute weather data, like temperature and humidity, to create risk maps. These forecasts help farmers know when the conditions are most favorable for an infection in their specific area. This allows them to time their fungicide applications much more precisely, making them more effective and often saving money by not spraying when it isn't needed. Ultimately, protecting our crops from diseases like Fusarium head blight is essential for everyone. It's about more than just one farmer's harvest. It's about maintaining a stable and safe food supply for the whole country. From developing tougher crops and smarter farming practices to creating advanced forecasting models, the ongoing battle against Fusarium graminearum is a perfect example of how agriculture, science, and smart regulation work together. By continuing these efforts, we can reduce the economic losses for farmers and ensure that the food that reaches our families is healthy and safe.